Imagine you're a newly hired engineer for NASA. Your first assignment for NASA is to consider a new return device that will help the air and spacecraft fall more slowly into a location of their choosing. The one design that is of interest is the rotor recovery vehicle. Right now, the RRV is an idea only on paper at this point, but it resembles something similar to a paper helicopter. It is a device attached to the craft or equipment, and it would deploy during descent. The device would use spinning blades to slow the fall of an object. How would you alter this design to decrease the rate at which the object falls and to predict the location of the landing? That's the problem that NASA is having with their current airspace models that are flying out. We're going to watch this quick crash discovery video so that you guys can learn more about the activity that we're about to complete. Discuss the goal for this challenge. So now I'm going to do a demonstration of following objects similar to what we saw in the video. So during my demonstration, everyone should have a POE sheet on their desk. Your predict, the observe, and the explanation sheet. Does everyone have that? Yes. Okay. I'll tell you what the event is, which is basically the first event. We have 5 events. The first event is a sheet of paper and a book. Okay, that's the first event, a sheet of paper and a book. Then you're going to predict what you think is going to happen as these 2 objects fall. After that, you're going to write your observation, and then you will give an explanation of why the objects fell, how they fell. Okay, so our event will be a book, a standard sheet of paper. Here they are in comparison of size. Okay. I want you to take about 30 seconds right now and write your prediction for this event. Okay, so as you see, I'm going to drop the book and the sheet of paper at the same height. And I'm going to go 1, 2, 3, and it's going to drop. Ready? 1, 2, 3. Okay, right now, write down your observation. And then take a minute to briefly explain why did those objects fall the way they did. Does anyone need to see it again? No. No? Okay. Okay. So everyone should have completed their observe and explanation columns from here. I'm going to go into our next fallen object. And here we have, can anybody tell me what these objects are? Coffee filters. Okay, coffee filters. Here I have 1 single coffee filter, and here I have a stack of 7 coffee filters. So we're going to go ahead and write down your event. We have a single coffee filter, and then we have a stack of 7 coffee filters. Take about 30 seconds to write down your event. Everyone should have written down your predictions for this fallen object. Okay? So I'm going to drop them again at the same height. I'm going to drop them at the count of 3. 1, 2, 3. Okay? Let's write down our observation and our explanation. For our next event, we have a coffee filter flower. It's 7, but they're spaced out like a flower. And then we have a single coffee filter. Go ahead and write down your event and the prediction for our third. And remember, guys, if you don't understand why an event is happening the way it is definitely okay for you to say, I don't know, on your paper. Okay? So for our 4th event, 3rd event, we have a single coffee filter. And then we have the flower filter. Same 7 coffee filters, but now they're spread apart. Still going to drop them at the same height. Okay? At the count of 3, can I get somebody to count?
1, 2, 3.
Okay? Do I need to do that one again?
Yes.
Okay, that's fine. If you don't need it again, go ahead and fill in your observation sheet. and your explain. If you need it and you need to see, that's fine. Stand up. Okay? Let me get someone to count.
1, 2, 3.
Okay, for our fourth event, we have the same white sheet of paper, but now I've crumpled it up into a ball, and then we have the same book. Okay? So everyone should have written the event and their prediction. 1, 2, 3, drop. That was bad. So for our fifth and final event, we have book, same sheet of paper. This time, instead of dropping it side by side like we did in the first event, I'm going to drop it actually on top of the book. Okay? So we're going to count. 1, 2, 3. Okay, so Adrian, can you explain to me how your prediction of compared with your observation from the second event with the single coffee filter and the 7 stack coffee filter?
First I had predicted that the stack of 7 coffee filters just dropped first.
Okay, was your prediction the same as your observation?
Yes.
Okay, and explain to me why did the 7 drop first?
Because the 7 coffee filters dropped first because it had greater mass.
Okay, because it had a greater mass, okay? Did y'all agree as a group on that explanation? The paper on top of the book. What was your prediction?
I said I didn't.
Okay, so what did you predict? I'm sorry, what did you observe?
The paper fell with the book at the same time.
Okay, but can anybody tell me why they fell at the same time?
Because it wasn't no area between the book and the paper, so the paper was close together to the book, so it didn't come off.
Right, very good, very good. Okay. The mission that we have, okay? Okay, go ahead and get in your areas wherever you decide and mess around, mess around. So basically what you're seeing here is our mess about phase, and during this mess about phase, my students are discussing with their partners how the RRV is behaving, the speed of the RRV, and 3 possible ways that could alter the design in order to get the desired results of NASA. So remember what
Well, me and my partner goal was to minimize the speed of descent and maximize the prediction of the landing.
Brandon, what are you noticing?
With added weight to the RV, the less air resistance, and the lighter it is, the more air resistance. And so it means the lighter it is, the less faster it falls.
I was saying when a fat person run, they gonna run slower. And when the skinny person run, they gonna run faster. But the RRV is showing that when they have more weight on it, it's falling faster. And when it doesn't have a lot of weight on it, it's falling slower.
The less the gravitational pull it has, the object, the more gravitational pull it has. The mass of the base, the less gravitational.
Of our mission from NASA was to redesign their aircraft and give it more of a way to fall down in a specific area and to have a slower descent. My hypothesis for a design change would be to add more mass to the bottom of the aircraft so that it has a more direct landing path, and to add longer wings so that there is less air resistance, and to add thrusters so you can move the aircraft to where you needed it to go if it got off course.
Okay, but we can have minimize speed in this area.
Okay. And
how to make an RV land in an atmosphere.
You should have kept
So it will make
but both of y'all groups
it'll
should
make the spacecraft
y'all not a group. Y'all look like y'all
have no control over the acceleration.
She's gonna wrap it around, man. But it's kind of like you do this.
So how to slow like really in a complete sentence. So I kind of still need you to go back and just kind of refigure your question. Good question, but you know, we got to learn how to do that bottom part one.
Stay here for this about that
Do the short one. 1, 2, ready, go.
You should have knew the longer ways about to go slow because you have seen the jet versus the airplane.
That's why I said logo.
I just did a short one.
Okay, so those are long ones, but how rich is it? Because yeah.
Now it's 1.45.
But
Holes right, bro.
Never gonna put out.
bro, why?
Oh, just stop. Bro, I got it.
Ellen, what are you guys using to as a tool of measurement? What are you using?
We're using a yardstick and we're using a stopwatch to measure the time.
Okay. Brandon, what's the distance you guys are dropping it from, Brandon and Maurice?
6.8 feet.
What was it?
6.8 feet.
Oh.
My name is Adrian, and I'm about to read to you my findings from my experiment. Although the size and shape of the RRV wing will help control the descent of the craft, the use of technology can help determine the location of the craft and the land. To help determine the location of the craft, RRV should be equipped with a tracking device similar to the devices used on a cruise vessel. Current technology allows weapons to travel great distance in order to hit a small target. The inertial guidance system could track the RRV as it travels back to Earth. The GPS system could be programmed to take the RRV to a predetermined landing spot using military GPS satellites.
We discussed the features and stability of the tail of the vehicle while increasing the surface area in contact with will increase the predictability of an exercise. Not to add too much mass, that the other hand, increasing the surface of drag caused by air friction will increase on the descent.
To decrease the speed of the descent of the rotor recovery vehicle, a net upward force must be acting on the RRV. In other words, an imbalance between drag and lift is required to minimize the speed of the fall. To maximize the net upward force on descent, the wing configuration has to be on one of the longer and increased surface area. The recommended configuration for the wings is that they are long with the ends folded downwards and folded zigzag appearance. I appreciate the opportunity to participate in this program and give a small contribution to the design process of the rotor recovery vehicle. Signing off, April Real.
And the layout.
What you're seeing right now are some of the students' work over the course of 3 to 4 class periods. This was their first inquiry assignment where they had to make a design suggestion to NASA for a rotor recovery vehicle that would minimize the speed of descent and maximize the predictability of landing in a single location. Their final product was to prepare a 2 to 3 page paper suggestion how to build the RRV. I extended the project by incorporating our current math standard for statistics and probability. The standards are listed at the end of the video.